Hi, I'm Christian and today we are going to talk about how Aligned is making data more flexible and easy to use. This video describes our work in the European Horizon 2020 project Aligned within a specific, but in fact very common use case scenario. Aligned is developing solutions for managing the complexity of building software that deals with large-scale data. This demo highlights work from Trinity College Dublin, Leipzig University, the University of Oxford, the Semantic Web Company, Wolters Kluwer Germany, and AMU in Poznan. The topic we want to address is a well-known issue in companies that have relational databases in place. These databases very often contain business-relevant data and are therefore well integrated in the company's data process flows. Problem is, however, that the database structure has grown over time, is very complex and not well documented. So actually nobody wants to touch the database structure because the impact is unclear and the risk that subsequent processes are corrupted is high. On the other hand, more and more data errors and workarounds are built within and aside the database so that maintenance costs and risk of system failure are growing rapidly. To create a completely new database is a major effort and success is not sure, since not all side effects are known in advance. Therefore, we are exploring novel re-engineering approaches. Fortunately, these approaches are avoiding by design most of the problems described above, so that we can be sure that within 5 years we are not in the same situation again as we currently are. In addition, the approaches enable us to address severe data quality issues and are therefore not only critical for the new and sustainable data model, but also for consistent and reliable instance data. On this slide, we present the IPG problem statement mainly around volume and complexity on the one hand and data quality issues on the other hand. IPG is a commercial intelligence system by Wolters Kluwer Poland with the following process. Data is gathered mostly as XML from various sources and processed through a proprietary CMS and a standard SQL database for content enrichment and validation into a final search index which serves data for the end user. As within Aligned, the software development lifecycle is mostly autonomous from the data lifecycle. Both of them are not changing very often, but are expected to change in the next few years as major upgrades are planned. A major problem is data quality, including missing or incoherent data as well as semantic inconsistencies, which could be detected and corrected by using aligned tools. Data is also expected to be enriched with data originating from new sources, including publicly available repositories and third-party datasets. This slide is showing a graph-based view on important business relationships that IPG manages. For example, information about companies and their internal structures with respect to subsidiaries, etc. The same goes for key people like CEOs and senior management in general. One core feature of the application is that the user can follow this relationship network over time and sees how companies and people move from one professional setting to another and how this influences the network partially or as a whole. All this information is very important, for example, in M&A, tax fraud investigation, and litigation activities. As shown on the previous slide, the added value mainly comes from the relationships, but also the sheer amount of information available is itself a striking sales argument. Typed company data, information about people, and associated documents create a huge information pool which then is accessible via a number of different structured relationships in addition to traditional searches. This diagram shows the top level of relationships within the application. Although this looks already rather complex, the main challenges lie beneath this level. Within Aligned, many partners have worked on solving the issues described above, and we think that we have achieved a solution which is very promising and has already proven its general applicability in a proof of concept environment with real data. In order to achieve this, we have used, integrated, and tested all four major Aligned tools: Model Catalog, Semantic Booster, the Cura, Unified Views, and RDF Unit. For more details on the tools themselves, we want to point you to our Aligned YouTube channel, where these tools are described in dedicated videos in more detail. For the IPG use case, we have done the following. A booster specification is created, which creates a model from the SQL database, along with formal constraints which ensure that the data remains correct by construction. The Model Catalog tool is then used to manage this data model. Semantic Booster is used to make this data available as RDF via an API. The Cura provides an alternative method for achieving the same results. In order to ensure that the results of the validation processes carried out by the Cura and Semantic Booster can be evaluated, the Unified Views tool is used to manage this mapping and transformation and to save the transformed data to a triple store. Finally, RDF Unit is used to run Sparkle queries against the transformed data to test whether the issues have been solved.
We used the model mapping tool to generate an OWL ontology, which becomes the dataset's schema. The curation tools allow us to view the shapes of the objects that have been imported. Then, we import all the instance data, with data quality analysis ensuring that it meets the constraints of the ontology. Next, we modify the schema so that it expresses the shape of the data that we want. OWL is much more expressive than SQL. We can create class hierarchies and all sorts of constraints within the data model. Finally, we migrate the data to the change schema and make it available as RDF through the Cura API. Any errors in the data are reported using Aligned's RVO ontology.
Based on our efforts so far, I would like to summarize the main findings and give you some additional hints in case your company is working on similar issues. These were the main challenges with respect to technology, data, and the overall process. It is important to start the transition from traditional to semantic technology. We adopted appropriate semantic web solutions in our infrastructure and were linking various components of these environments. With respect to data, to improve data quality in large and complex databases by enforcing constraints automatically, saving manual effort not just in tracking errors, but also in correcting them. In our current process, the administrator interface requires manual coding each time the database changes, increasing the cost of evolving the data store. The model-driven Semantic Booster default interface can be used to save these efforts. In addition to the challenges, here are some more general lessons learned that we have incorporated in our thinking. Use semantic technologies for data-intensive systems and datasets, as it will help to better describe, understand, communicate, and validate the data. Integrate targeted, dedicated components that play nicely together so that you can achieve a major technological upgrade of your overall solution. Please don't start with a big design upfront approach. Start small and take small steps by integrating one tool after the other. Semantic technologies are well suited for these iterative approaches. We will further work on evaluating the added value of the Aligned tool stack for our Wolters Kluwer products. Thanks for your attention.